All right, so um, let's dive into this X-ray imaging thing.
Okay.
It's pretty amazing, isn't it? Like getting to see right through stuff.
Yeah.
We usually think of it as just taking a picture,
Right.
but there's way more to it than that.
Oh, yeah. A lot more.
You sent over this really cool simulation. It's called X-ray imaging physics.
Yeah.
It lets us play around with how these X-ray pictures are actually made.
Uh-huh.
This deep dive is going to be all about understanding what makes a good X-ray image.
Okay.
So before we get into the actual simulation itself,
Yeah.
can you give us like a quick overview of how X-ray imaging even works?
Sure. So basically, X-ray imaging uses radiation
Okay.
to create images by looking at how different materials absorb X-rays. Denser things like bone,
Yeah.
they absorb more X-rays,
Yeah.
and they show up brighter on the image.
Okay.
And then less dense things like soft tissues.
Like muscle and stuff.
Yeah, exactly, like muscles and fat and organs.
Okay.
They let more X-rays pass through, so they end up looking darker.
Makes sense.
That difference in absorption is what creates the contrast, so you can actually see the different structures inside.
So it's kind of like shining a light through different materials.
Yeah, that's a great way to think about it.
Some block more light than others,
Exactly.
and that's what creates the patterns you see.
Yep. And to get a really clear and useful X-ray image,
Mm-hmm.
there are a few key factors we have to control.
Okay. Like what?
Well, first, there's the quality of the X-ray beam,
Okay.
like how powerful it is, how much it can penetrate.
Right.
Then there's the quantity of X-rays produced.
So like how many X-rays there are?
Exactly. And we also have to think about something called filtration.
Filtration.
Yeah, it's like fine-tuning the beam to remove some of the rays that could actually blur the image.
Interesting. So it's not just point and shoot.
Nope, it's way more nuanced than that.
Right.
There's a lot of fine-tuning that goes into getting a really good result.
Okay. I see.
And that's where the simulation is going to come in handy.
Right. Because we can play around with it.
Yeah, we can adjust all the settings and see how they change the image.
That's awesome.
Yeah.
So what will we actually be seeing when we use this virtual X-ray machine?
Okay, so you'll have a main window that shows the X-ray image.
Right.
It's like looking at a real X-ray on a computer screen.
Cool.
And there'll be controls to change all sorts of parameters, like the energy of the beam
Yeah.
and how many X-rays it produces.
So we're basically in control of all the settings on the X-ray machine.
Exactly. You can think of it as having all the knobs and dials right there in the simulation.
That's pretty neat. What about the thing being X-rayed? Is that adjustable too?
Absolutely. So the simulation uses a standard setup.
Mm-hmm.
It's a slab with 2 cylinders embedded in it.
Okay.
And you can change what the cylinders are made of. You can change their size.
Right.
You can even adjust the thickness of the slab itself.
Wow. So it's like having a customizable phantom patient
Exactly.
that we can experiment on without any risk.
Right.
Now, you mentioned some important settings we can adjust for the X-ray beam itself.
Yeah.
What were they again?
The 2 most important are KVP and MAs.
Okay.
KVP stands for kilovoltage peak,
Hmm.
and it controls how much energy the X-rays have.
Mm.
So a higher KVP means the X-rays can pass through denser objects.
Oh, so like if we want to see through bone, we need to use a higher KVP.
Exactly.
Makes sense. What about mass?
So mass stands for milliampere seconds,
Okay.
and that one controls how many X-rays are produced.
Right.
Generally, more X-rays means a brighter image.
So KVP is like choosing a more powerful flashlight beam,
Yeah,
and mass is like making that beam brighter.
that's a great way to visualize it.
I like that. Okay, so the simulation lets us play around with both of these and see how it affects the picture. That's awesome.
Exactly, and it updates in real time, so you see the changes immediately.
Now, I remember you mentioned filtration earlier.
Yes.
What exactly does that do to the X-ray beam?
So filtration helps remove some of the lower energy X-rays from the beam.
Mm-hmm.
Those lower energy rays don't really help us see anything, and they can actually scatter around and blur the image.
So it's like adding a filter to our flashlight to make the beam more focused.
Yes, exactly.
That's helpful. So by filtering out those useless rays, we make the picture clearer.
Exactly. You improve the contrast between different things in the image.
Gotcha. So we've got control over
Right.
how powerful the X-rays are,
Right.
how many there are,
Mm-hmm.
and we can filter them for better clarity. What else can we change?
Well, another important one is the source-to-image distance, or SID.
SID. What's that?
It's just the distance between the X-ray source and the film or detector.
So like how far away the X-ray machine is from the patient.
Exactly, and changing that distance can affect how bright and sharp the image is.
Oh, just like if you move a flashlight closer or farther from something.
Yes, precisely.
It changes how it's lit up.
Okay. The simulation lets you experiment with that too.
So we can see how the image changes with different distances.
Yep. And it also lets you compensate for a dimmer image.
How do we do that?
You can adjust the NMAs, the number of X-rays.
Right, so we can brighten the image up if it's too dim.
Exactly. The simulation helps you see how everything works together.
To get a clear picture, even when things change.
Oh.
Okay.
Yes.
Wow, it's really cool how all these adjustments work together to create an X-ray image.
It is.
It's definitely more complicated than I initially thought.
Oh, for sure. There's a lot going on, but that's what makes it so fascinating, right?
Definitely, this simulation seems super helpful for understanding all the nuances.
It really is.
It's like having our own virtual X-ray lab.
Right.
Where we can try stuff out and learn.
Uh-huh.
Before we get into that, though,
Yeah.
I think it's important to understand what we're actually seeing when we look at these simulated images.
Right.
Like, what do those shades of gray actually mean?
Good point. I think we should definitely explore that.
All right, cool. Well, let's do that then.
Okay.
All right, so we're back and ready to dig a little deeper into those X-ray images.
Okay.
Last time we were talking about all those settings we can adjust.
Yeah.
But I'm still curious about what we're actually seeing,
Right.
When we look at the image itself, those different shades of gray,
Okay.
what do they actually represent?
So basically, those shades of gray show you how much radiation different materials are absorbing.
Okay, so if an area is darker,
Uh-huh.
that means it absorbed less radiation.
Exactly. And a brighter area means more absorption.
Gotcha. So that variation in how much gets absorbed
Yeah.
is what creates the contrast.
Right. It's what lets us see the different structures.
Like bones and organs.
Exactly. And that's why understanding how all those different settings affect that absorption pattern is so important.
It helps us make sure the image is showing us what we need to see.
Right. A bone, for example, is
Yeah.
really dense. So it shows up white because it absorbs a lot of X-rays.
Okay, that makes sense.
And then softer tissues, like muscles,
Right.
they don't absorb as much, so they appear as shades of gray.
Okay, so it's kind of like a density map.
You got it.
That makes sense. So it's not just about taking a picture. It's about creating an image that accurately represents what's inside.
Exactly. And that's where all those settings we talked about come in.
The KVP and MAs and all that.
Right. KVP, MAs, filtration, source to image distance, they all play a role in how much radiation different tissues absorb.
Okay, I see.
Remember how we talked about filtration being like putting a filter on a flashlight?
Yeah, to make the beam more focused.
Exactly. So how do you think that affects what we see in the X-ray image?
Well, if it's making the beam more focused,
Mm-hmm.
I guess it would make the image sharper.
Right. That's a big part of it. Those lower energy X-rays we filter out,
Yeah.
they tend to scatter within the body, which can blur the image.
Oh, so it's like getting rid of some of the haze.
Exactly. And that helps us see those finer details more clearly.
Okay, that makes sense. So by filtering, we're basically improving the contrast between different structures.
Right. It's like fine-tuning our vision to see more clearly.
I like that analogy.
Yeah.
Okay, so what about the source to image distance?
Ah, yes, the
Okay, go ahead.
SID.
Right, we talked about how it's like moving a flashlight closer or farther away.
Uh-huh. So what happens when you move the X-ray source farther away from the detector?
Well, if it's like a flashlight, I guess the light would spread out more.
Right. It spreads out over a larger area.
So that would probably make the X-ray image dimmer.
Exactly. And it can also make it less sharp.
So it's kind of like trying to read in dim lighting.
Yeah, the details get harder to see.
But you said the simulation lets us adjust for that, right?
Right. You can change the MAs to compensate for the lower intensity.
So we can make the image brighter again.
Exactly. You got it.
Awesome. It's fascinating how these little adjustments can have such a big impact on the image.
It really is. It highlights how much precision is involved in getting a good X-ray.
Absolutely. Okay, so we've talked about what we can see in the image.
Right. The shades of gray.
Yeah. But there's probably a lot going on that we can't see as well, right?
Oh, definitely. There's a whole lot of physics happening behind the scenes.
Like what kind of stuff?
Well, we touched on scatter earlier. When we were talking about filtration,
Right.
scatter is a big deal in X-ray imaging.
Okay, so remind me what scatter again.
It's when some of the X-rays don't travel in a straight line through the body.
Oh, right. They bounce around off of stuff.
Yeah, they interact with the atoms in your body and change direction.
So it's like some of the light from our flashlight is bouncing off objects instead of hitting the target.
Exactly.
And that's bad for the image, right?
Yeah, scatter is basically noise in the image. It can make it harder to see what's going on.
So we want to minimize scatter as much as possible.
Exactly. And that's why we use techniques like filtration and collimation.
What's a collimation?
It's like narrowing the beam of the flashlight.
Oh, okay, so it's more focused.
Right. It helps to reduce the amount of scatter that reaches the detector.
I see. And the simulation lets us play around with that too.
Yep. You can see how different techniques affect the amount of scatter in the image.
That's really helpful. This simulation is amazing. I'm learning so much.
I'm glad to hear that.
We've covered so much already. It's really incredible how much goes into creating these X-ray images.
It is.
And it all starts with those basic principles we talked about.
Right.
Understanding how X-rays work and how to control them.
Exactly.
And create a clear and accurate picture.
And of course, how to do it all safely.
Right. Patient safety is always the top priority.
Absolutely.
Okay, so now we have a good grasp of the basics.
Yeah.
I'm ready to try out some of those activities you mentioned.
Great. Are you ready to put your X-ray knowledge to the test?
Let's do it. All right, so let's dive into those activities you mentioned.
Okay, so they're built right into the simulation.
Cool.
And they walk you through different scenarios.
Like what?
Well, one of them simulates a chest X-ray.
Oh, perfect. We were just talking about how different body parts need different settings.
Right, exactly. Like with the chest X-ray.
Yeah.
You have to think about the chest wall and how thick it is.
Right.
And then the lung tissue behind it, which is much more delicate.
So we'd need to use a higher KVP to get through that chest wall.
Exactly, you got it.
And probably adjust the MAs too, right?
Yeah, to make sure we're getting enough X-rays for a clear picture.
But not too many.
Right, we don't want to expose the patient to more radiation than necessary.
It's all about balance.
Exactly, it is. And that's one of the things the simulation helps you learn,
Okay.
how to adjust those settings for different situations.
So it's not just knowing what KVP and MAs mean.
Right.
It's about knowing how to use them.
Exactly. It's like having a recipe, but also understanding how to actually cook.
You need both the knowledge and the experience.
That's a great way to put it.
So we've talked a lot about image quality,
Yeah,
but what about safety? X-rays are radiation, after all.
that's a really important point.
Yeah.
X-rays are super helpful for diagnosis and treatment,
Uh-huh.
but we always want to minimize the radiation exposure.
Of course. How do we do that?
Well, there's this principle called ALRA.
LRA.
Yeah, it stands for as low as reasonably achievable. Basically, it means we always try to use the lowest possible radiation dose that will still give us a good image.
So just enough to get the information we need.
Right, exactly. And that's where the skill of the X-ray technologist comes in.
Okay.
They're trained to choose the right settings for each patient and each exam.
That makes me feel better knowing there are people who are experts at this.
Oh, yeah, definitely. They play a crucial role in keeping patients safe.
Technology has probably helped too, right?
Oh, absolutely. Like digital imaging, for example. It's
Yeah.
way more sensitive than old school film. So we can use lower doses and still get the same quality image.
That's awesome. It seems like X-ray imaging keeps getting safer and more effective.
It really does. And there's so much innovation happening all the time.
Like what kind of stuff?
Well, there's 3D imaging, new contrast agents, all sorts of exciting advancements.
It's amazing how far we've come from those early X-ray images.
It is pretty incredible.
This has been such a fascinating deep dive.
Yeah, it has.
We started by talking about how X-ray images are made.
Right, the basic physics.
Yeah, and now we're talking about all this cutting-edge stuff.
It just goes to show you how much depth there is to this field.
Totally, and it all comes back to those fundamental principles.
Uh-huh. Understanding how X-rays work, how to control them.
Right, and how to use them safely.
Exactly.
So for anyone listening who's interested in X-ray imaging,
Okay.
or maybe even thinking about a career in radiology,
Mm-hmm.
what would you say is the most important thing to keep in mind?
I'd say never stop learning.
Oh, good one.
This field is always changing.
Right.
So be curious, ask questions, embrace new knowledge.
The more you know, the better.
Exactly. The more you understand about X-ray imaging, the more you can help patients.
That's a great message to end on.
I think so too.
Thank you so much for guiding us through this amazing deep dive.
It was my pleasure. I really enjoyed our conversation.
Me too. And to everyone listening, thanks for joining us. Until next time, keep exploring.